Alright, so today we're going to add a few more trig functions to the cosine, sine, and tangent that we already are familiar with. These are reciprocal functions, which literally just means it's the reciprocal, secant is the reciprocal of cosine, cosecant is the reciprocal of sine, and cotangent is the reciprocal of tangent, which just means whatever answer you would get for cosine, you would flip to get an answer for cosecant. So that means we can write them all in terms of, we can write all three of these in terms of cosine, sine, and tangent. We can also write them in terms of x and y on our unit circle. And if our unit circle is, or sorry, if our circle is not a unit circle, so if our radius isn't 1, we can write it in terms of x, y, and r. So I'm going to kind of walk through the whole process here. So for cosine, we know cosine is adjacent over hypotenuse. So that's the first way you learned it, right there. And then on the unit circle, the adjacent side is the x, or sorry, on a circle in a coordinate grid, the adjacent side is x and the hypotenuse would be the radius, but in a unit circle, the radius is 1, so for the unit circle, the cosine is always equal to x. So if secant is the reciprocal of cosine, and they're next to each other because secant is the reciprocal of cosine, one way to remember that, this starts with a c, ends with an s, starts with an S, ends with a C. So it's the reciprocal of this, which means in general, it would be the hypotenuse over the adjacent side, which is the same as R over X, which is on the unit circle, 1 over X. And another way to look at it is just, it is 1 over cosine of theta. So whatever you get for an answer for cosine, you would just write it as 1 over that for your fraction for secant. So if I want to talk about sine, similarly, sine is opposite over hypotenuse, good old geometry. On a circle, on a coordinate grid, that would be the y-axis, the upside versus over the radius. The hypotenuse is the radius. In a unit circle, the radius is 1, so that would just be y. So cosecant is the reciprocal of sine, so it's just flipping all of these. It would be the hypotenuse over the opposite side, which is the same as the radius over y. Or for us on the unit circle, I guess I should put little arrows here because it's not necessarily always equal to that. It would be 1 over y, and that is the same as 1 over sine. So when you're asked to do problems and find answers for secant and cosecant and cotangent, the strategy really is to figure out which reciprocal function it is, get the answer for cosine, because those are the ones we're familiar with, and then just flip it to get your answer for secant. And finally for tangent, there's a lot here for tangent. Tangent is opposite over adjacent, and we learned that that was going to then be y over x. We already talked about this, which is the same as saying sine of theta over cosine of theta. There's no r in here because it'd be y over r and x over r, and the r's would cancel whether they were 1 or not. So cotangent is the reciprocal of tangent. That's the easy one to remember because they have the same name in them, tangent, cotangent. So that means cotangent is the reciprocal of all of these. So in a regular triangle, that would be adjacent over opposite. For us, it's going to be x over y, and it would then be cosine over sine. So again, you are going to encounter these, and when you do, your first job is to figure out which one is the reciprocal of, find the answer for that, and kind of go forward from there. So we're going to try a couple. I'm on the bottom of this page. Secant. So again, the first thing I would do is, if this is secant, then what I'm going to do is I'm going to find what the cosine of pi over 3 equals, because secant, as I scroll up, is the reciprocal of cosine. It's 1 over cosine. And this is where the unit circle comes in. So I have a unit circle right here, pi over 3. Cosine is your x value, so the cosine of pi over 3 is a half. So then if I'm going to answer this, cosine of pi over 3, I use my unit circle, that's a half. So the secant of pi over 3 has to be the reciprocal of this. So the secant of pi over 3 is just going to be 2 over 1, or 2. So again, for cosecant, I ask myself which one of the 3 is cosecant or reciprocal of, and I may not know yet, so I look up here. Cosecant is the reciprocal of sine. So what I'm going to do is I'm going to find what the sine of 5 pi over 4 is, and then I'm going to flip it to get that answer. So I know that this has to be a rad 2 over 2 because it's over 4, and all of the sines and cosines are rad 2 over 2 for your fourths. 5 pi over 4, so I'm going to try to do this without the unit circle in front of me. 5 pi over 4 is going to be over here, because this would be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. And in that quadrant, we are both sine and cosine are negative, so sine would be negative rad 2 over 2. And the cosecant is the reciprocal of this, so if I want to find the cosecant of 5 pi over 4, again, it's basically finding the sine of 5 pi over 4 and flipping it. So it would be negative 2 over rad 2. We're not allowed to have radicals in our denominator for whatever reason, so if I rationalize this, this would equal 2, so I would have negative 2 rad 2 over 2, and those 2's would cancel, and it would be negative rad 2. And remember, when we first found the 5 pi over, or the pi over 4's, we were getting those as 1 over rad 2's, and then we simplified it to get the radical out of the denominator, but when I reciprocate it, it pops back down in the bottom. All right, so cotangent, that's an easy one. I know that is the reciprocal of tangent, so I'm going to find the tangent of 7 pi over 6. That is not a very good looking 7 pi over 6, so I'm going to find the tangent of 7 pi over 6. And tangent is, again, y over x. So I'm going to use that little hint, and I'm going to come over here. And actually, we can do this kind of two ways, because cotangent is x over y. So if I can just find the coordinates for 7 pi over 6, I can jump to that answer. So if I go to my unit circle, 7 pi over 6, I've got to move down a little bit. There it is. This is x, this is y. So I need to put those over top of each other. So tangent is y over x, so it would be negative 1/2 over negative rad 3 over 2. And cotangent is x over y, so it's going to be, that's my x and that's my y. So I'm going to go back, and hopefully I can remember that. It would be, I am not even in the right place now. So I'm going to do cotangent, jump right to cotangent. It was negative rad 3 over 2. Y was negative 1/2. The negatives, two negatives make a positive, and then the 2's in my denominator are going to cancel, basically. Or if you think about it, dividing by 1/2 is the same as multiplying by 2 over 1, and the 2's cancel, so this equals rad 3. And this one would have equaled 1 over rad 3, and then you would have had to simplify it, because we would have had 1/2 over negative rad 3 over 2. If we put y over x's, 2's cancel, negative divided by negative is positive, and so they're reciprocals of each other. So again, the strategy is kind of recognizing this, either the coordinates, or you can find the original trig function that it's a reciprocal of and then just flip the answer. Either way works. And so if we wanted to practice a few more of these, there's a couple on here to practice. I'm not going to do a whole bunch of them, but we'll look at this one. Cosecant is the reciprocal of sine. So I know that I've got to find the sine. I'm going to find the sine of 5 pi over 3, and you can use your unit circle if you need to. 5 pi over 3 is way over here. The sine of 5 pi over 3 is the y coordinate, so it's negative rad 3 over 2. So that means that the reciprocal of negative rad 3 over 2 is negative 2 over rad 3. And if I rationalize that, I would get 2 rad 3 over 3, and it would be negative, and that would be my answer for cosecant. You know, some of these are 900 degrees or negative. We can look at those as well. 900, just you got to find the reference angle to 900 degrees. That's what we were doing earlier to be able to answer that question. I'm going to jump up to these two, because these two are kind of interesting. So the tangent of negative pi is, again, y over x, and negative pi is going this way, and the coordinates right here are negative 1, 0. Again, that's negative pi because I went clockwise, and it's y over x, so this would equal 0 over negative 1, which is 0. And tangent of 0 degrees is going to be similar. You're just going to stay right there and use those coordinates. So sometimes you're going to land on not the triangles, you get on the axes, and that's okay. And now that we've talked about tangent and sine and cosine, there's one other thing to keep in mind very quickly. In this quadrant, all of your trig functions are positive. In this function quadrant only the sine ones, which means sine and cosecant. In this one, just tangent are positive, tangent and cotangent, and that's because sine and cosine are both negative. And since tangent is sine divided by cosine, the two negatives make a positive. So only tangent is positive in this quadrant. And in this fourth quadrant, just cosine and its reciprocal function secant are positive. So this is usually math teachers say to remember that all students take calculus, so you remember which trig functions are positive in which quadrant. But it's kind of silly because all students don't have to take calculus. It's just a quick acronym. All right, you're going to just practice a few of these. Again, it's just more practice on that unit circle, and try your best to start trying to get them without looking at your paper plate. But if you have to look at your paper plate, that's cool too.